Hi, I'm Liz, and I'm here to show you how to translate a line segment using a vector. First, let's put our line segments up here. Boom, a line segment. But if we're translating, which means we're moving the object, then we need to know what direction we will be translating the line segment in. And we can tell this by using a vector. So we're going to put our vector in any direction over here. Let's do it here, make it easy. Alright, so we have our vector, which tells us the direction that our translating is going to go in. So what we want to do first is to connect C and A, make line segment CA. And then we're going to make a circle connecting C and A. So with a circle at the center and a connecting. Let me scroll up a bit. There we go. And then our second step is that we're going to copy the circle on over to point D. So now they are both the same size. And just to make things easier, because this construction will have a lot of circles, I am going to be coloring the circles themselves. So now we have this, and for the sake of it, for steps, I'm gonna color this too. All right, so we have our two circles and we have our line segment. Our next step would be to make circle AB. Let's go back down to our circle tool and make AB. And then we're going to make circle CD. All right, let me go back up here and change the colors of these lovely circles. Let's make it green. And this one orange. That was not supposed to happen. Alright, that's because I selected both of them. Alright. So now we have so many circles and we're only going to create more. So using these circles here, you can start constructing a parallelogram. And we are going to be constructing a parallelogram by putting a point E on circle D and circle A's intersection. So excuse me, not circle D and circle A. I mean circle D and circle C. Because we're making a parallelogram. So let's put our points. Where is my point? There's a point. On the intersection. And you will notice here that E cannot be moved. That is because it is located on the intersection of two circles, and because of that, it just won't be able to move. You see these here, which they're not on intersections, so they're able to move freely. But E cannot because they're stuck between the two. Alright, so now let's complete our parallelogram by connecting D and E, and then E to A. So there we go, we have our first parallelogram. But how is that going to help us translate our original line segment? You see up here, we didn't move the line at all. So we're going to be building more circles and using this parallelogram as a guide on where to move our segment AB. So first, let's differentiate our little parallelogram here. I can never find the tools. There we go. I'm gonna just make a quick little polygon here just to kind of see that, just so it pops out. And then we are going to make a circle that is the same size as circle C to D on point B. So let's take our compass tool, wherever that would be on here, right here, and put it on point B. is the same size as circle CD. So with that, we're gonna be making point F on here. So I can move things around so I can see everything better. All right, so we're going to be making point F. Wait, I'm getting ahead of myself here. I am so sorry. We will be making circle E first. There's so many circles, it's easy to lose track. All right, so yeah, we're going to be making circle E. That's about right here. To make it the radius, a horizontal radius between B and F, right here. And now that we have point F as the intersection between these two circles, then, well, it's not quite the intersection, is it? I mean, we can move this around, but it's not really. All right, so the reason we can move F, the reason we can move F but not E is that E is the center of two different circles, but F is part of circle E. It's not a new point altogether. So I just want to clarify that. So now we have circle E and our point F, and if you can see where I'm going with this, we're going to be connecting E to F and F to B to create another parallelogram. So let's do that. E to F and F to B. We see here that we've created another one. Let's point that out. Let's put it over here. And make this the color, I don't know, black or something. All right. So now that we've created two parallelograms, we're going to be comparing our work. So we see that in the beginning, we only had a segment AB with vector CD. CD was telling us where to move, where to translate a line segment AB. And by connecting the vector to the line segment and creating a whole bunch of wild circles, we created a parallelogram that we used as a guide to create another parallelogram. Because we see here that if the line segment is in relation to the vector, then the opposing translation will be parallel, at least in this example. So that's why we made the parallelograms, so we can know where to translate our original line segment. And you can see that between AB and EF, they are both the same size. They are parallel from each other. And because we used CD as a guide to show us not just where to put it, but what size, how far away it should be, we constructed a parallelogram AEFB. And because sides in a parallelogram have to be, across from each other, these are the same line segment. So we have translated segment AB over to the right just a little bit. So segment EF is literally the same line as AB. And we've proven that by using the vector CD. So I hope this has been helpful, and I'll see you all later. Bye!